for our assignment today, we are going to finish the notes that we didn't get finished in class yesterday, and then you're going to also finish the rest of the worksheet that you guys had in class. So you should already have all the papers that you need. We had stopped right here where it says estimating rates of change at a point on our notes. And in this picture that we have here, it tells us that the graph of F is shown above, along with the line, and the word that we want to use right here is tangent to F when x equals -3. So in this picture right here, that curve is your f of x, and the tangent line is this line right here. And you can see that it just touches that graph at one point. In calculus, we will learn that the slope of the line tangent to the graph of f of x at any point gives our true rate of change at that point. However, we can't really do that with AP Precal, but we can sketch it and guess. So that's a strategy that we're going to be using here. So it says, for example 6, it tells us to estimate the rate of change of f at x equals -4, using the slope of the line tangent to f at x equals 4. This is the tangent line they already have drawn in for us. So they drew the tangent line. We have to estimate the slope of that line. Now, what is a little bit tricky about this is that it doesn't hit perfectly at grid lines, and this is the problem with estimating. So you can see here that our line is right here. This ends pretty much at a point we are pretty close to being up 3 to the right 2. However, it's not quite 3 over 2. So what I would probably say for this here, that it is a little less than 3/2. 3/2 is 1.5. It's 1.5. So I might even say something, maybe something like 1.4 could be a good guess here. Of course, I'm not going to ask you a question like this on a quiz or a test where you're just guessing, but I could give you this problem as a multiple choice question with multiple answers available, and the one that is close to 3/2 would be your answer. I wouldn't give you like 1.4 and 1.5 and 1.3, but I might give you answer choices like -2, 0, 1, or 1.4. And you would be able to determine between those a little bit better. Okay. Example 7 asks us to sketch the tangent lines to F at the 5 points indicated on the graph above. So there's points on this graph, and we're supposed to graph tangent lines to this graph. So at this point right here, let me use some different colors actually. Let's use green right here. The tangent line is going to be the line that just touches one time. I think this one is kind of hard to draw in. I think it would be something about like this. That piece of the graph is almost linear, so it almost looks like it is the line itself. I think that's a little bit difficult of a tangent line to draw. This next one is a little bit easier. You're just going to have the line kind of skim the graph like that, just barely touch it. That would be a tangent line at x equals 1. Let's use orange for our next point. This point right here, it looks like that sort of is like the bottom point. It looks like you would have a horizontal line as your tangent at that point. Over here, at this point, you're definitely going to have a positive slope, like so. And then at your last point, what color have I not used? Red. You would have a tangent line that just barely, no, that's not very good, that just barely touches there. It's going to be a pretty steep line for this. So those would all be our tangent lines at those points. The question at 8 asks, does the graph of f appear to have a greater rate of change at x equals 4 or x equals 5? Explain your reasoning. So x equals 4 is right here with this purple line, and x equals 5 is right here at the red line. And these are pretty close. It's a little hard to tell. But if you think about how this graph is increasing, it looks like it's getting a little bit steeper as you go along. So I would say in this case that the rate of change is a little bit higher at x equals 5 than it is at x equals 4. You can also tell that this graph looks like it is concave up. And since that graph looks like it is concave up, the rate of change should be increasing here, which tells you that 5 should be your highest rate of change. So I would say F has a higher rate of change. At x equals 5. And for your reasoning that you're explaining, you could give a couple different reasons. You could say something like, because the tangent line has a steeper slope. Or another option, you wouldn't need to put both of these, but you could say because F appears to be concave up on the interval so the rates of change should increase as x increases. Both of those would be good reasons to give for example 8. Okay. This next part of your graph is really just a restatement of that chart that we had on the notes earlier. It's telling you that if a rate of change is positive, then the graph of f is increasing. If the rate of change is negative, the graph of f is decreasing. If the rate of change is increasing, the graph of f is concave up. If the rate of change is decreasing, the graph of f is concave down. To me, it's a little bit helpful to think of it in that chart form where you've got f and rate of change of f. And so if we think about what's happening here, if we have an increasing graph here, my rate of change is positive. If I have a decreasing graph here, my rate of change is negative. If my graph is concave up, then my rate of change will be increasing. If my rate of change is, if my function is concave down, then my rate of change will be decreasing. So if we look at this next graph that we have here, it says tells us the graph of f is shown above. Complete the blanks below to correctly describe the graph of f and the rate of change of f. So this first statement is talking about the graph of f, and the second part of the statement talks about the rate of change. So whenever we're looking at f, it just says the graph of f is either increasing or decreasing. As you go from left to right, f is increasing. And concave. In this case, this is concave down. Because the rate of change of f is, and then it gives us options here. So knowing that the graph is increasing means that our rate of change is going to be positive. So you could think about those little line segments that we talked about. You also could think of like little tiny tangent lines is another way you could think of it. So if I draw in all these little tiny tangent lines right here, the slope of all of those lines are positive. So we would have a positive here. And the rate of change is blank. So I could use my table here. If f is concave down, the rate of change should be decreasing. I could look at that. Or if I think about like my little tangent lines here. My tangent line's pretty steep here, and then it gets a little less steep. So like if I want to put numbers on that just as a guess, this might be a slope of 2. And if that's 2, maybe this is just 1. And if that's 1, this is a little less steep, so it might be 1/2. And this might be 1/4. Those numbers are decreasing as we go from left to right. So we would have decreasing. Here for that problem. Be careful when answering questions about graphical behavior. Pay close attention to the wording of each statement. Does it refer to f or the rate of change of f? And you have to be really careful with that on these problems. So here are some examples that we're going to look at. In this graph, the first column here asks me about f. The second column asks me about the rate of change of f. So if I'm asked about the graph of f being positive or negative, this is asking me if it's above the x-axis or below the x-axis. To say a function is positive, the function itself is positive, is to say that it lies above the x-axis, or to say that it's negative says that it is below the x-axis. So in this particular case here, this will be positive because this entire graph here is above the x-axis. And then the graph of f is either increasing or decreasing. On this, you just want to start on the left, go towards the right, see if you're going up or down. You are definitely decreasing right here, so you would be decreasing for the graph of f. Now that was looking at the graph that they had given us. When we talk about the rate of change of f, then that's not necessarily true for positive or negative. So if the rate of change of f is positive, if we go back up here to that little table that we made, if rate of change is positive, it means that f will be increasing. And if rate of change of f is negative, it means f will be decreasing. So in this particular case, our graph is decreasing, right? So these two right here are linked. The graph of f is decreasing, so the rate of change of f is going to be negative. You can also think about drawing in all those little tangent lines. And you can see all of these little tangent lines right here are negative slopes. All those little tiny lines are decreasing, so you have a negative rate of change. When we talk about whether the rate of change is increasing or decreasing, that has to do with our concavity. So if I look at the concavity of this graph, this is concave up. So if my graph, if I go up here to this table again, my graph is concave up, then the rate of change of f should be increasing. So for this, just going straight from the table, I definitely know since this graph is concave up, my rate of change should be increasing. To think about what that means, think about these little tangent lines. They all have negative slopes. This slope is very steep. This slope is not very steep at all. So if we wanted to put numbers on this, maybe this has a slope of -4. Well, this one's a little less steep, so it might be -3. And this one might be -2, and -1, and -1/2, or something of that manner. So those numbers are increasing. Sometimes it's hard to say that those are increasing because the magnitude is not increasing, but they are increasing because they're negative numbers. So -4 is less than -3. -3 is less than -2. So the rate of change certainly is increasing here. If we look at our next graph for this, in this case, we would say that the graph of G is negative. And we are saying that this graph of G is negative because it falls below the x-axis. The graph of G is also going to be increasing here. Now when we talk about rate of change, remember we're not talking about the graph that we're looking at. Since these two right here are connected, if my graph is increasing, then my rate of change is going to be positive here. That means if I draw in all these little tangent lines here, the slope of those tangent lines are all positive. And if I think about what's happening with those tangent lines, I need to think about concavity. So this is concave down. A graph that is concave down is going to have a decreasing rate of change. Again, you can kind of think about numbers. This is a very steep slope, so it might have a slope of something like 4. This is less steep, so maybe it's just 2. This is less steep, so maybe it's 1. Maybe this is 1/2. Those numbers for our rate of change are decreasing. Okay. To look at our last example here, for this graph is going to be called positive, and we know it's positive because it's above the x-axis. I don't know why it's going crazy right there and writing it. It's moving what I'm writing. That should say above the x-axis. This graph is also going to be decreasing. Like we've seen on the other problems, this question is directly related to the next question. The rate of change of h is going to be negative. Okay, if we think of drawing in a bunch of little tangent lines right here, all of those tangent lines have negative slopes because they're decreasing. Now, our rate of change in this case, we're thinking about concavity. This is concave down, and if a graph is concave down, the rate of change is going to be decreasing. It's not quite as obvious on this one. Those tangent lines are all pretty similar, but this one, I might even not have that one drawn all that good. Let's put one up here. That one should be a little flatter. So we're not very steep here, and as we go to the right, it gets a little bit steeper. So maybe this just has a slope of like -1/2. And then here, maybe -1. And then here, -2, maybe here, -2.5 or 3, something like that. But it's getting a little bit steeper. Now, I had to pause there for a second because I was almost thinking, hold on, these numbers are increasing. But they are not increasing because we're talking about negative numbers. So -1/2 is higher than -1. And -1 is higher than -2. These numbers are decreasing here because they're negative numbers. So we'll have that. So use this information to help you answer the rest of the questions on that 1.2 worksheet that you had. On Monday or whenever we're back from the snow, I will check that, and then we'll move on to 1.3. Our quiz that we were going to have on Monday is definitely going to be moved back at least a day, possibly further.